Well, this is 2014 paper 2 question. It was question 1 that came up on trigonometry. So we're told that we're given this diagram here, and I'm just going to fill in the lengths. They said AB was 120, they said BC was 134, and they said AC was 150. And they'd asked us to get CBA. So CBA, so it's this angle in here that they wanted us to get. Now, this isn't a right angle triangle, so we can't use Pythagoras and we can't use sin, cos and tan. The only things that we can use when we have our non-right angle triangle is the sine rule or the cosine rule. And there's kind of like a handy little kind of trick I would use that, do we use the sine rule, do we use the cosine rule? And I would ask myself the question, do I know one side and its opposite angle? So to start, do I know one side and its opposite angle? If the answer is yes, use the sine rule. If we know one side and its opposite angle, use the sine rule. If the answer is no, I would use the cosine rule. So in order to use the sine rule, we need to know one side and its opposite angle. But if we look at this diagram, we don't know any of our angles. So we can't say that we're going to use, we know one side and its opposite angle. So we're going to have to use the cosine rule. So the diagram that they give us, so it's on page 16 of the formula and tables. So they give us, say we have a triangle here. So this is the diagram that they give us. So say if you're like wondering how we'll use the cosine rule. So they give us this diagram on page 16 and they say a squared is equal to b squared plus c squared minus 2bc cos of a. So basically the angle that we want, we're only going to have one angle in the cosine rule, but the whole thing, the angle that we want is, and the side opposite that angle side A, is going to have to be in the front here. If we had angle B here, this would have to be side B. If we had angle C here, this would have to be side C here, and the other two sides fall in. So if we look at our diagram that we are given, so we have 134, 120, 150. So we're looking to get this side here. So maybe let's call this angle A. So let's call this angle A. Well then side A is going to be the side opposite the angle. So A is equal to 150, and it doesn't really matter what I call the other two because it doesn't really, so let's call this B and this C. So then if we're going to be working this out, so A squared, which is 150 squared, is equal to b squared, which is 134 squared, minus c squared. I think I'm going to run out of space here. I'm going to go on to the next line. Minus 2, and then b is 134, c is 120, and then cos of a. And ultimately, I'm going to try to get cos of a. So 150 squared. So I'm just going to put 150 squared. Sorry, that should be plus 120 squared, so 150 squared minus this, so 150 squared. So just when you're doing it out, I'm going to put it all in brackets. 150 squared minus 134 squared minus 120 squared. So that gives me minus 98. So I just move these two over to that side. 5, 6 is equal to minus, so 2 by 134 by 120 cos A. So maybe if I multiply, so 2 by 134 by 120, so that gives me minus 9856 is equal to minus 32160 cos A. And if I want to get cos A, I'm just going to divide 9856 by 32160, and I get cos A. So cos A is equal to So I get 308.1005. So if I want to get, they asked me to get this angle A, so they asked me to get this angle. So cos of my angle is equal to, so we're going to have to get cos inverse of that, so 308/005, so it's equal to 17.15 degrees. So that's this angle here. So say we well, this angle was in the question, it was actually called angle B, but when I did my calculations, I forgot that it was called angle B, and I just called it angle A. So we could just swap, if you wanted to do it another way, we could put B squared is equal to, and then we put angle B. But I just called this in my question angle A. But I just labeled it angle A myself, but really the angle is called ABC, and that's equal to 72.15. So I just called that angle A when I do my calculations. So find the area of the triangle ACB according to the nearest whole number. Well, the area of a triangle, so say our triangle, I'll draw it again, so 120, 134, 150, and we know that this angle here is, so I got that it was 72.15. So to get the area of a triangle, it's area of triangle is equal to the half the base by perpendicular height. Or there's another way, area is equal to a half AB sin C. So we don't know the perpendicular height, but we do know the lengths of the sides. So if we took this side as side A, let's just call this side A. So whatever side, two sides and the angle in between, and let's call this side B, and let's call this angle C. So it's two sides and the angle in between. So that's what we use for our area. So a half, so 120, 134 sin 72.15. So half by 120 by 134 by sin 72.15. So then I get the area is equal to 7652.972, but they asked correct to the nearest whole number, so the area would be 7653 meters squared. So that is the area of our triangle. And then the next thing they asked us to get, so you're gonna just rip out this page here. So a vertical mast, so we have a triangle, and then we have this here, and here we have all these points here. So this is point D, this is point A, this is point B, this is point C. And if we read out what they're after giving us, it says a vertical mast is fixed at the circumcenter of the triangle. The mast is held by three taut cables, and EA, EB, and EC. Explain why the cables are equal in length, and it's placed at the circumcenter. Well, first, when we're given this information, we're going to need to know what the circumcenter is. Well, the circumcenter, if we have a triangle, so it's fixed at the circumcenter. So say if we just had a triangle, well, the circumcenter is formed by where the triangular's circumcenter equals where triangles three perpendicular bisectors meet. So say this is say we got the perpendicular bisector of this line. Say it was here, and so let's just pretend, say this is the same distance here and here. So say this is the perpendicular bisector. So it's just rough. Say this is the perpendicular bisector of that side here. So that's length is the same as that length. So it halves the length of the sides, and say this is here the perpendicular bisector of this line. So that just means this side is the same as that side, that's the same as that, and that's the same as that, because they're perpendicular bisectors. And just because the perpendicular bisector, this comes at a right angle here, and this comes at a right angle here, and this comes at a right angle, and then right angle. And then, so this is the center of our circle, and then, so say if we wanted to draw, so our circle would look something, well, obviously this is just rough, but that's circumcenter. So, the first thing it says that, the vertical, so we have in our triangle, we have a point fixed at the circumcenter. Well, the circumcenter is a point, so we have a point, it's fixed at the circumcenter of the circle. So the circumcenter, so here we have, so each of the triangles, so we're told that the circumcenter here is at D, A, B, C, and we are asked to figure out so we want to get that, explain why the three cables, so we want to show that so we wanted to show that EA is equal to EB is equal to EC. Well, first, if we have our circumcenter, well, say this is going to be our circle, say this is the center of our circle, and then the circle goes through each of the vertices of the triangle. So say this is a really bad circle, but so the distance from the center to any point on the edge is the radius. So DA is a radius because the circle goes through the vertices of the triangle, and this is the center. So DB is a radius of our circle, and DC is a radius. So AD is equal to BD is equal to CD, because they're with the radii of our circumcenter. So then if we wanted to, well, if they're all the same, all these lines, all these are the same, well then this is the same as this, is the same as this. So we know that much. So so DA, so each of these triangles, if we wanted to see how, so consider, so say if we wanted to consider so we know that those lines are all the same, but say if we wanted to look at, say that the top of our triangle is E, but say we want to look at EAD is going, so say, sorry, I'll just draw a better diagram so I can explain it properly. So this is D, so D, E, A, B. So if we compare the triangles, so we want to show that A is equal to E, and this is C here, EB is equal to EC. So we're going to compare the triangles EAD and triangle EBD and triangle ECD. So we know that I just showed that AD is equal to BD is equal to CD. So they because they're say from the circumcenter, they would be the radius to the edge of the circle, so radius. And so say if we're comparing, well, each of the triangles is going to have the same line ED, so ED is equal to ED for each of the triangles. because that's the same pole that they're both going by. And then, so if that's going to be, and then also it's going to be where they come up to the pole, the vertical mast, that's going to be a right angle. So it's right angled at D. So then it's a right angle triangle. So we're after showing that, say we just take EAD. So AED. So it's a right angle. We showed that all these sides were the same here. We showed that all these sides were the same here. Well, by the theorem of Pythagoras, all this was the same and all this was the same. So by the theorem of Pythagoras, there's only one other side that it could be. So if so EAD and EBC and ECD are right angled at D, and so the triangles are right angled at D and have two sides, have the two sides of the base, the base of the triangle and the perpendicular are equal. So the perpendicular and the base of each of them are equal. Then by the theorem of Pythagoras, the third side of each, which is the hypotenuse, which they call the cable in the question. Hypotenuse, the cables must be equal. So that's just shown there. So I think that is the end of that question there. I hope you found this helpful. Thank you.